Factor the given trinomial. If the trinomial cannot be factored, indicate not factorable. That will be the case on some of these. All right, we have x squared plus 3x minus 18. So the first thing we want to do is we want to take a look at our middle term, actually the coefficient in front of our middle term, and then our back constant. And we want to look at it with the negative out in front of it. These two numbers we're going to use. We're going to be looking for two numbers that multiply to give us this negative 18. And we're looking for two numbers that add to give us this positive 3. So one thing I like to do is make a t-chart, and I like to list off all the different factors that gives me negative 18. And it adds to give, well, we'll look for the ones that add to give us 3. But let's list them off. Now, if we're adding to get a positive, we need to make sure that our bigger number is the positive. So when we say that a negative 1 and an 18 multiplies, remember, a negative times a positive gives us a negative. So when we add those together, that gives us 17, and that's not what we're looking for. We know that negative 2 and 9 give us negative 18, and added together, that still does not give us 3, that gives us 7. If we do negative 3 and 6, that's our next one. It's also our last one. We don't have any other numbers that add to give us that, but that does give us that positive 3. So these are your two factors. Now I'm going to show you the long way to do it, and then I'm going to show you the short way to do it. Eventually you'll probably just stick with the short way, and it works when you don't have a number in front of your lead coefficient. What happens with these two numbers is this middle term splits into these two numbers. So this thing becomes a positive 6x, and it becomes a negative 3x. And then we have minus 18 on the front term, and the last term stayed the same. And you can imagine if we added these back together, we get that. So it's still the same equation. Now we're going to do what we learned in 13.1, and we're going to factor by grouping. If you do that, we can take out an x here. The only thing left here, we took out one x, and we had two of them, so there's one left over. And we took away the x here, so only the 6 is left. And here we can factor out, remember we lead with the negative, we can divide these both by 3. And so after we take out the negative 3, the x is left, and then negative 18 divided by negative 3 is a positive 6. You'll notice that once again we get these things the same, that x plus 6, and then we do the things on the outside of the parentheses in our other parentheses, so that's x minus 3. So the easiest way to do it is you really don't have to do these two steps, because you figured out what this was. You got the negative 3, which became this right here, and that positive 6 became this right here. So when you don't have a lead coefficient, you can basically just skip straight from this step to this step. In 13.3, we're going to be doing a lot of this because we have to. Once again, we're looking for what multiplies here, adds to give us this. If we list off all the factors of 12, now keep in mind, we have a negative thing that we're adding up to b. So this is going to take us needing two negatives to get to this, because two negatives multiply to give us a positive, and that's the only case where we can end up with a negative sum and a positive product. So when we do our negative 1 and our negative 12, that doesn't add to give us that. We do a negative 2 and a negative 6, that still doesn't add to give us that. And then we can do a negative 3 and a negative 4, and we find that that's what gives us that answer. And so we got x minus 3 and x minus 4. Find all the pairs of integer factors of the given integer. Remember to include negative integers as well as positive integers. That's really important. So if we're listing off all the factors of 18, we know we're thinking of two things that multiply to give us 18, and we know that 1 and 18 give us that, right? We know that 2 and 9 give us that. We did just list that right up here. And we know that 3 and 6. You'll notice these numbers keep getting closer and closer together, and once you kind of fill in, we know 4 and 5 don't give us 18. Now what it means by the negatives, we know that a negative times a negative gives us a positive as well. So we have to list the negative versions of these numbers as well. -1 and -18. We got -2 and -9 and 3 and -6. All are. All right, something that multiplies to be this, adds to be this. List off all our factors. We got a 1 and a -4, and that right away that does. The only other thing that could give us is 2 and -2, and that gets us 0. So this is what we're looking for. So this answer should be x plus 1 and x minus 4. Now in this one, you'll notice that we do have something, we have a coefficient. That's a number out in front of our variable. We do have one on our lead term. And when that happens, it might indicate that you can have a greatest common factor. We learn that we can take that we can take a greatest common factor out of each term. We know that we can divide each one of these numbers by 2. And so we want to take that out to start this problem out. So if we divide each one by 2, we should get x² minus 9x and plus 18. Now, once again, we're back at what we were doing here. We're looking for things that multiply to give us 18 and add to give us -9. And we don't really have to even list them off. I typically don't if I've got kind of a list here. Now, I know that I'm multiplying to be a positive 18 and adding to be a -9. So both these would be negative. And so if these were both negative, that would be -19. That would be -11. And this is the one that would give me -9. So we still have our 2 out in front, but this thing splits into x minus 3 and x minus 6. Don't forget that 2 out in front. Here's another one that has greatest common factor. You'll notice that, and that's one question you want to ask yourself when you're doing these, is does my problem have a greatest common factor that I can take out right at the beginning? And all these things have an x in it. So let's take out, so that gives us x on the outside. We got x² plus 14x plus 24. So let's try to do our t-chart. And we got 24 here. So these are all positive. So all we're dealing with is positives here. 2 and 12 and 3 and 8, 4 and 6. I'm just getting the habit of just listing them out, but we found it. It's right here. So this is x on the outside, and then we have x plus 2 and x plus 12. And the order of these things doesn't matter. Typically, you want to put your greatest common factor on the outside, but as far as your linear factors, you could put x plus 12 here and x plus 2 here. All right, this is our first problem where we don't have x's, but it still means all the same. So we're looking for what multiplies to give us this, adds to give us this. And these numbers might creep up on you, and there is a little thing on a calculator if you have one of these TIs. If you want to get a list of what your factors are, you could actually go to your y equals button, and you can type in this number that you have, this -36. So you can type in -36, and then divide it by, and then you're going to hit this button right here. It's going to put an X there. And then you're going to hit second and graph. And this gives you the list of it. And you'll notice that it's exactly what we're doing with the t-chart. We're looking for numbers that give us positives, though. if we want to look at it like that, we're doing -1 and 36, -2 and 18, -3 and 12, -4 and 9, and then we're going to kind of ignore the ones that have decimals in it. That doesn't really count as being in factors. We want them to be integers is what we want them to be. And then we got a -6 and 6. And the one that adds up and gives us 12 is none of these. Yeah, because as you add these up, this gives you 35, this gives you 16, this gives you 9. And you'll notice that if you kind of skip over this number, you're not going to have it. So this one is not factorable. This one has a really interesting greatest common factor. We know that we can divide all these things by 5, and we can also take out a u squared out of each one of them. So what's left behind is u to the second, because we took away 5u squared out of this. Now we're going to have -4u, and then 60 divided by, or -60 divided by 5 is 12, and we took away all the u's. Now we still have to double check and see if we can split these into two linear factors. Do a t-chart with the -12. Remember, we're adding to be a negative, so we want our bigger number to be negative. So 1 and -12. We get 2 and -6, 3 and 4. And we did find something that gives us -4. So we still want to keep our 5u squared on the outside, and this will split into u plus 2, u minus 6. Once again, we can take out a greatest common factor on this one. We can divide these all by 2. This would give us x² minus 5x plus 4 after we divide each one of these by 2. And then if we're thinking about 4, we're adding to be a negative, so both of them are going to have to be negative. If we got a negative middle number and a positive last number, so this would be -1, -4, -2, and -2. Now this is what we're looking for. 2 on the outside, and then we got x minus 1, x minus 4. The area of the rectangle is given by the polynomial function. A of x is equal to 2x² plus 20x. If the width of the rectangle is 2x, what is the length? All right, so this is just telling us our area is equal to this. Now, if you remember what the formula for a rectangle is, it's just width times length. So we have our width, we're looking for what our length is. That's kind of the mystery thing that we're solving for. This is going to be multiplied by something to give us what our area is. You can think about it like we're taking this out of this. So you could think about it like it's a greatest common factor. We can take out our 2x, and we want to find out what's left over after we take out our width from the area. Now we took away the 2, we took away the x, so just an x is left behind. And if we take 20 and divide it by 2, that gives us 10, and we took away the x. So this is all that's left. So here's our width, and this would be our length. So this is x plus 10. We got -72 as our back number. We have to think about this middle term being a 1. That's always understood if they don't have a number in front of a letter. Even up in front of this one, this is a 1 as well. So we're multiplying to get a -72 and to get a 1. So we got 72 here. We're going to list off all the factors. You're welcome to do it on your calculator. And we're trying to get a positive. So our bigger number needs to be the positive. So -1 and 72. We got -2 and 36. We got -3, 24. We got -4 and 18. We got -6, 12. And 7 doesn't work, but we got -8. And I might have made a mistake in there, but this is what we're looking for. I know this adds, multiplies to give us -72, and adds to give us 1. So this is going to split into v, and we do want to make sure that we're using the same variables, v minus 8 and v plus 9. Okay, this one's not too bad. Really, I mean, it's what we're doing here. Okay, and this is the first part, and they've already given us one of these parentheses, just like it would be like they already gave us this one. So it's saying something multiplies with 4 to give us negative 36, and something multiplies with, or adds with 4 to give us negative 5. Okay, and if you're a little confused on what that might be, it's easy just to use your calculator. Let's do that. And let's pull up what multiplies to give us that negative 36. So let's go back to our y equals. We already have negative 36 in. We'll do second graph. And we're looking for something with 4. So let's go find positive 4. And we'll find its counterpart. That easy. And we know it's negative 9. Those add together to give us negative 5, and multiplies together to give us that negative 36. So we know that n minus 9 belongs in our other spot. And you don't need to put it in parentheses. You're just expressing that's already got the parentheses up there in that blank anyways. For the two numbers listed, find two factors of the first number such that their product is the first number and the sum is their second number. So we're looking for something that multiplies to give us this. That's what product means. And then we're looking for something that adds to give us this 2. Well, we can do a t-chart with this negative 3, and we know that negative 1 and 3 gives us 3, and then we know that 1 and negative 3 gives us this. And then if we added these up, this would give us that positive 2, this would give us a negative 2. So it has to be a negative 1. The area in square inches of a rectangle is given in the polynomial function a of b is equal to b squared plus 5b plus 6. The width of the rectangle is b plus 3 inches. What is the length? This one is a lot like what we did here. They've given us the width and we're looking for the other half of it. So instead of a greatest common factor, they've kind of given us something that we dealt with here. They gave us one of these linear factors already. We just have to figure out what the other one is. So we know that it's something that adds with 5, or adds with whatever the other number it adds together with that to give us 5, but it multiplies to give us 6. And that's pretty easy for us to see what that is. We know that 3 plus 2 is 5, and 3 times 2 is 6. That gets us there. So that is our length. They're going to let us finish with an easy one. We're looking for things that multiply to give us 8, adds to give us 6. And these are all positives, so we know 1 and 8, 2 and 4, and that's as big as our list goes. We found it right here. So this should be x plus 2 and x plus 4. And that concludes our lesson on 13.2.